Tonight, I want you to slow down, take a breath, feel the air move gently in and out of your lungs. That rhythm, that pulse, it's not so different from the heartbeat of a star. Welcome to Dreams of Science. Tonight, we'll drift through billions of years in the space of a few heartbeats. We'll witness the life of a star, its birth, its burning, its beauty, and its death, and discover how every flicker of starlight is also a reflection of you. Because somewhere out there, in the deep silence between galaxies, a star is being born right now. And once, long ago, one of those stars gave birth to you. So close your eyes if you wish. Let's begin at the edge of nothingness. Chapter 1: The Birth of Light. Before there was light, there was silence. Not the kind of silence we know, the absence of sound, but a silence so vast it felt infinite. A quiet sea of dust and gas stretching across space like a forgotten dream. Hydrogen, the simplest atom, the universe's firstborn element, floats here, cold and patient. For millions of years, it drifts aimlessly, pulled by the faint tug of gravity. Imagine it, a cloud the size of a constellation, spinning ever so slowly, its edges curling inward like the breath before a word. We call it nebula, a stellar nursery. It is both a graveyard of old stars and a womb for new ones. Somewhere within this mist, a ripple forms, a tiny imbalance. And in the cosmos, imbalance means creation. Atoms begin to gather, clouds thicken, the temperature rises one whisper at a time. Gravity, invisible yet unstoppable, begins to pull everything together. If you were here, you wouldn't see it happen. It's too slow for human eyes. But you'd feel it. The soft pressure of existence building, the weight of destiny gathering mass. Over thousands of centuries, what was once a faint cloud becomes a sphere, and that sphere is growing warmer. Gravity is the great artist of the universe. It takes chaos and sculpts it into stars. As the gas collapses inward, atoms crash into one another with increasing speed. Each collision releases heat. Each moment draws the particles tighter, denser, brighter. The heart of the cloud, the core, glows a soft red now, hidden within dust. It's called a protostar, a child not yet ready to shine. Inside, the temperature climbs toward 10 million degrees. It's a number that barely fits inside our imagination. 10 million degrees, hot enough to fuse hydrogen into helium, to turn matter into light itself. And when that fusion begins, when hydrogen surrenders its form and releases pure energy, that's the moment a star is born. A single spark erupts in the darkness, and for the first time in its existence, the universe breathes light into that corner of space. It is not a loud birth. There are no cries, no explosions, just illumination. A new sun ignites, soft and blinding, and everything nearby begins to orbit its glow. We often think of stars as eternal, fixed, unchanging, but this newborn sun, is trembling. Its light flickers, unstable. It burns too hot, then too cold, adjusting its rhythm like a heartbeat learning to steady itself. Over time, millions of years, it stabilizes. It finds balance between two forces, gravity pulling in and fusion pushing out. That balance is what defines life, both cosmic and human. It's the dance between collapse and creation, between surrender and strength. Every second, trillions of hydrogen atoms collide at its core. They fuse into helium, releasing photons, packets of light that journey outward for thousands of years before they ever escape the surface. The light we see from a star is ancient by the time it touches us. It's a message sent across eternity, finally delivered. This young star begins to shape the space around it. Winds of radiation push away leftover gas and dust, clearing the cradle it once slept in. What's happening here is simple, yet divine. Hydrogen, the same element inside the water you drink, is fusing into helium, releasing light and warmth. That's the same light that will one day warm planets, ignite atmospheres, and awaken life. From this process alone, the conversion of matter into energy, the universe builds everything it knows, from the smallest cell to the largest galaxy. All of it begins here, inside the quiet heart of a newborn star. Scientists call this stellar nucleosynthesis, but in simpler words, it's the universe learning to shine. Every spark of fusion is a lesson that even the smallest particle, when united with another, can release unimaginable energy. And perhaps that's true for us too. When we connect, when our separate atoms of thought, hope, and kindness fuse, we create light that wasn't there before. If you were drifting in the vacuum nearby, you would see this star emerge like a slow dawn. Its light reaches out, cutting through dust, illuminating what was once hidden. Nearby clouds begin to glow, reds, purples, and blues, as the star's radiation excites their particles. This is the universe's first sunrise in that patch of sky. And though countless others will follow, this one is special because for a moment, creation remembers itself. Light exists again, and with it, the possibility of life. Every atom in your body, the carbon in your skin, the oxygen in your lungs, the iron in your blood, all of it began in stars just like this one. When they lived, they burned. When they died, they scattered. And in that scattering, they planted the seeds for you. You are not a visitor in this story. You are its continuation. Somewhere 13 billion years ago, another star like this took its first breath of light. It burned, it lived, and when it ended, its ashes became the building blocks of your existence. You are quite literally the dust of old suns, walking, thinking, dreaming. So tonight, when you look up at the night sky, remember every twinkle you see is not just light, it's a beginning, a story billions of years old, still being told in silence. Next time, we'll drift closer into the middle years of a star's life to see how it grows, sustains worlds, and burns with a purpose so vast it almost feels human. Until then, breathe. You are part of the same universe that learned how to shine. Chapter 2: The Middle Years, a Star's Quiet Life. Light has a way of forgetting how long it's traveled. When a star is born, its first instinct is to shine endlessly, faithfully, without hesitation. But over time, that light settles into rhythm. It finds its balance. And so begins the longest chapter in a star's life, the age of stability, the era of quiet creation. Every star, from the faintest red dwarf to the blazing blue giant, is defined by a fragile balance. At its core, nuclear fusion pushes outward, while gravity, ever patient, pulls inward. These two forces, opposites in every way, hold each other in perfect tension. Too much gravity, and the star collapses. Too much pressure, and it explodes. But in the middle, it lives. This is the miracle of equilibrium, the same delicate harmony that lets your lungs expand and contract without thought, that keeps your heartbeat steady, that lets Earth orbit in peace around its own star. At this stage, the star burns hydrogen steadily, fusing it into helium, not violently, but gracefully, turning matter into light in an endless cycle of transformation. Every second, our own sun, a modest star among billions, converts 600 million tons of hydrogen into energy. Yet, it does not weaken. Because as long as the dance continues, so does the music. Now, picture this. The star has been shining for 1 billion years. Its glow has carved a small empire in space, a realm of warmth and gravity. Around it, dust and debris have coalesced into planets. Some are barren and frozen, some boiling and bright, and one, just one, is wrapped in oceans and dreams. That's how it often goes. From one star's patient burning, life finds a foothold. Its light travels outward, touching atmospheres, stirring molecules, awakening chemistry that one day begins to think. When you stand beneath sunlight, you are literally standing inside the breath of a star. Light that left its surface 8 minutes ago and decided to rest for a moment on your skin. It warms you because it recognizes you. After all, your atoms once burned in its ancestors. Let's go deeper now into the heart of a main sequence star, where the real work of the cosmos happens. At the core, temperatures reach 15 million degrees. Hydrogen atoms, pushed together by immense pressure, fuse into helium. Each fusion releases energy in the form of photons, tiny particles of light. But that light doesn't escape right away. It bounces endlessly for tens of thousands of years, ricocheting through layers of plasma before it reaches the surface and finally bursts into space. The light that reaches your eyes tonight might have been born when mammoths still walked the earth. Every star carries within it a time delay, a reminder that even light, the fastest thing in the universe, must wait before it's seen. And maybe that's a quiet lesson for us that even brilliance takes time to emerge. Millions of years pass, then billions, but for a star, time flows differently. It does not rush, it does not tire, it simply exists, constant, luminous, patient. From our human view, that feels eternal, yet inside, the clock is ticking. Slowly, almost imperceptibly, hydrogen indigo is running low. Each fusion reaction adds helium to the center, creating a dense inert heart surrounded by a shell of fire. It's like a candle burning from the inside out. The wax of hydrogen thinning as light continues to pour forth. Still, for now, the balance holds. And so the star continues to shine, a billion-year meditation in the language of light. Look around it. This star does not live alone. No star ever does. Across the galaxy, hundreds of billions of others are burning, each with its own worlds, its own story, its own quiet audience of moons and stones and cosmic dust. Some are small red dwarfs, cool, dim, destined to outlive everything else. Others are massive blue giants, burning so fiercely that they will live only a few million years. There's poetry in that contrast. The humble stars live the longest, while the brilliant ones burn out the fastest. A reminder, perhaps, that sometimes greatness comes not from how brightly we shine, but from how long we endure. Back near this particular star, the one like our sun, something extraordinary has begun to stir on one of its planets. Beneath blue oceans, chemistry has learned to copy itself. Molecules have begun to remember patterns, and as eons pass, those patterns begin to see, to move, to feel. Light, once only the product of fusion, now becomes the spark of thought. That's the silent triumph of the middle years of our star. It sustains, it nurtures, it gives energy freely without asking for return. Without the calm constancy of this phase, life would never have the chance to exist long enough to wonder where it came from. Every star that shines steadily across millennia is a sanctuary for possibility, a cosmic hug where existence can learn to dream. We often live our own middle years like that, don't we? Steady, predictable. The great explosions behind us, and the quiet work of sustaining ahead. But maybe that's not dullness. Maybe that's grace. The same kind of grace the universe gives to its stars. There's something holy in constancy, in showing up every day, quietly burning, quietly giving warmth to others. The universe runs not only on explosions, but on the steady hearts that keep burning even when no one's watching. So tonight, if you feel ordinary, remember this. The sun itself is ordinary, and yet, because of it, everything extraordinary is possible. Chapter 3: The Weight of Time. Time does not hurry the stars, it simply waits, patient, endless, certain. Our star has been burning for billions of years now. Its rhythm, once effortless, has begun to strain. Inside, the balance between gravity and fusion, that delicate cosmic dance, is beginning to falter. It's hard to notice at first. From a distance, the star still shines, golden and steady. Its planets still orbit, their days still unfold. But within, deep in the furnace where hydrogen once flowed freely, change has begun. The hydrogen, the star's most precious fuel, is running low. And when the fuel runs low, even the universe must adapt. At the star's core, the story is shifting. Hydrogen, after billions of years of fusion, has become helium. Helium, heavier, more inert, begins to collect in the center, forming a dense, unmoving heart. The core contracts under its own gravity, pulling inward with increasing pressure. As it collapses, the outer layers expand, like a deep inhale before a sigh. The temperature soars hundreds of millions of degrees. Hydrogen in the outer shells reignites in a frenzy, creating a storm of light and energy that pushes the star outward. It swells larger, redder, colder at the surface. A transformation so vast it would swallow entire worlds. The star has become a red giant. From afar, it is magnificent, a crimson orb glowing like a slow ember in the dark. But up close, it's chaotic. Currents of plasma twist and churn across its surface, thousands of times larger than the world it once warmed. If you could stand on one of its planets, if it hasn't already been consumed, you would see your sky filled entirely by fire. The horizon would be nothing but light. The star, once gentle, is now immense and unstable, its outer layers drifting away in waves, its gravity barely able to hold its own radiance. And yet, there's a strange grace in this decay. This is not a death of despair, but of generosity. The star is giving itself away, sending its matter into space, preparing to become something new. As the outer layers expand and cool, they form vast clouds of glowing gas, rings and ripples of color that stretch for billions of kilometers. These are planetary nebulae. Though they have nothing to do with planets, they are the final exhalations of dying stars, their last attempt to give back what they once gathered. The gases shimmer, red from hydrogen, green from oxygen, blue from helium, a cosmic watercolor fading slowly into night. And at the center of it all, the shrinking core continues to contract. It grows denser, hotter, until it begins to fuse helium into carbon and oxygen. This is the star's second phase, a brief blazing encore before the final silence. But this stage doesn't last long. A few million years at most. A blink in the life of cosmos. Every star eventually faces a question it cannot avoid. How long can I hold on? The fusion that once defined its existence now struggles against gravity's hunger. The heavier elements in its core refuse to fuse further. There is no more energy to push back. And when there is nothing left to give, gravity wins. The outer layers, no longer supported, drift away into space. A wheel of stardust that will one day seed new worlds. What remains behind is small. A hot white sphere no larger than Earth, but containing the mass of an entire sun. A white dwarf. A star's ghost. It no longer burns with fusion, but glows with the leftover heat of what once was. It is the memory of light, lingering long after the flame. In this stage, physics becomes poetry. The white dwarf is sustained not by heat, but by the quantum pressure of electrons, a strange state of matter that defies collapse. Its surface burns at 100,000 degrees, but over billions of years, it will cool, dim, and fade. Eventually, trillions of years from now, it will become invisible. A black dwarf, cold and silent, its light finally gone. No human will ever see one. The universe is not yet old enough for that. But one day, in the distant future, when galaxies have dimmed and the cosmos itself grows cold, these black dwarfs will drift quietly, like embers floating in infinite night. Even then, they will carry within them the story of creation. It's strange, isn't it? Even the sun, that eternal symbol of constancy, will one day fade. 5 billion years from now, it too will become a red giant, swallow Mercury, Venus, and perhaps Earth. Its final breath will paint the sky with color, and what remains will be a single glowing ember. But this is not tragedy. This is transformation. Every end in the universe is also a beginning wearing a different face. The matter the star releases will drift across space, becoming part of nebula. New clouds will one day birth new stars. That's how the cosmos renews itself. It burns, it breaks, it rebuilds. And perhaps we do the same. Maybe the stars are teaching us something about surrender, about how, even in collapse, there is creation. When the star expands into a red giant, it isn't failing, it's sharing. It gives away its material, its light, its warmth, so that something else may live. That's the same stardust that will one day form mountains, oceans. The star rests now. Its life, measured in billions of years, has come to an end. But its death is not the end of the story, because from its ashes, something new will rise. Next time, we'll drift into that next chapter, the supernova, the great unmaking that becomes rebirth, and witness how even destruction can create the very building blocks of life itself. Chapter 4: The Death, a Final Symphony. There comes a moment in every star's life when it must decide what kind of ending it will have. Some, like our sun, fade softly into white dwarfs, a quiet goodbye whispered across time. But others, the massive ones, the giants of creation, refuse to go quietly. They end in fire, they end in brilliance, they end in an explosion that shakes the fabric of the cosmos itself. Imagine a star 10 times the mass of our sun. Its life has burned fast and fierce, fusing hydrogen into helium, helium into carbon, and now, near its end, fusing heavier and heavier elements in rapid succession: oxygen, neon, silicon, sulfur, nickel, until finally it reaches iron. But iron is different. Iron does not yield energy when it fuses. It consumes it. It is the wall every massive star eventually hits, the end of the road. At this moment, the star's core is enormous and unstable, a furnace of unimaginable heat. Yet, it cannot sustain itself. There is no more fuel to resist gravity. The heart begins to collapse. In the span of a single second, the core implodes. Atoms crushed so tightly that protons and electrons merge into neutrons. The core becomes a solid sphere, smaller than a city, denser than anything we can comprehend. The infalling layers of the star slap into this neutron heart and recoil outward. Then everything explodes. There is no sight in the universe like a supernova. It's the brightest, briefest event in a star's lifetime. A cosmic heartbeat that outshines entire galaxies. In a single moment, the star releases more energy than our sun will emit in its entire 10 billion year existence. Its outer layers are hurled into space at unimaginable speed, creating shockwaves that ripple through the galaxy. Matter, once locked within the star, is suddenly free. For a few days, the star's brightness can be seen from millions of light years away. Ancient humans once watched these appear in their night sky, recording them as new stars, unaware they were witnessing the universe's most powerful act of renewal. But even as the outer layers scatter, something remains behind, something extraordinary. At the center of the explosion, the collapsed core may take one of the two forms, both equally awe-inspiring, both beyond human comprehension. If it's small enough, about 1 to 3 times the mass of our Sun, the collapse stops at the neutron stage. The result is a neutron star, a sphere no wider than a city, but so dense that a teaspoon of its matter would weigh billions of tons. It spins rapidly, sometimes hundreds of times per second, its magnetic fields beaming radiation into the dark, creating cosmic lighthouses known as pulsars. But if the core is heavier still, gravity wins completely. No pressure, no force, no law of physics can stop the collapse. The core becomes a black hole, a place where gravity pulls space and time inward, where not even light can escape, a singularity, the universe's deepest silence. To us, a supernova might sound like destruction, but it's the opposite. It's creation at its most magnificent. You see, in that explosion, the extreme heat and pressure forge new elements: gold, silver, uranium, iodine, copper, zinc. Every heavy atom in your body, everything beyond iron, was created in a supernova like this. Your bones contain calcium that was once flung from a dying star. Your blood carries iron born in the heart of another. Even the gold in a wedding ring, that shimmer of eternity, was once dust scattered in the wake of a stellar death. So when a star dies, it doesn't end, it gives. Its fragments become nebulae, colorful clouds of gas and dust that float through space until gravity gathers them again, compressing them into new stars, new planets, new beginnings. It's a cycle of endless generosity. If you could listen to a supernova, it would sound like a chord played on the strings of the cosmos itself. Each vibration, each wave of light, gamma ray and neutrino, is a note in the universe's most powerful song. It's a soundless symphony, felt more than heard, echoing through space and time. And perhaps that's why, when we look at the night sky, something in us feels still. Because on some level, we are hearing it. The faint resonance of ancient stars, still singing the song of their own ending. There's a strange serenity in knowing that even the most violent events in the cosmos are acts of love in disguise. The star, in its final breath, gives everything it has ever been: its mass, its light, its memory, to the universe around it. And though it vanishes, its influence ripples outward forever. In that way, stars are not so different from us. We too burn brightly for a time. We too give of ourselves. And when we go, the warmth we shared, the ideas, the love, the small acts of kindness continue in others long after our own light fades. Perhaps that's the truest form of immortality. Not to last forever, but to give something that does. Chapter 5: Stardust and Memory. When a star dies, it does not vanish. Its ashes scatter. Particles of carbon, oxygen, nitrogen, iron, all the elements that once burned inside it, now floating freely through the galaxy. For millions of years, these fragments wander in silence. They drift through the dark, drawn by invisible threads of gravity, carried by the soft currents of time, and then, slowly, inevitably, they begin to gather again. Somewhere deep in the quiet arm of Milky Way, a new cloud begins to form, a swirl of gas and dust, woven from the remains of ancient stars. You could call it a graveyard, but really, it's a garden. Every atom here has lived 1,000 lives as part of stars, as part of planets, as part of creatures who once looked up and wondered. Gravity pulls the dust inward, the same ancient rhythm repeating itself. The cloud collapses, heats, ignites, and from the ashes of the dead, a new star is born. Its light is fresh, but its matter is not. It carries in its core the memory of all that came before. This is how the universe remembers. Not through words, but through recycling its own brilliance. Some of the stardust never joins a star again. It travels farther, colliding with other clouds, coalescing into planets, moons, asteroids, the small bodies that orbit in quiet devotion. And on one such planet, circling star, a peculiar thing happens. The dust begins to think. It combines into molecules, which combine into cells, which begin to feel the warmth of their parent star and reach toward it. Over time, these cells learn to see, to remember, to dream. Eventually, one of them looks up at the night sky and whispers, Where did we come from? And the answer, though it takes billions of years to be understood, is simple. From here, from the stars, every piece of you, your bones, your eyes, your breath, was once part of something vast, burning in the dark, long before the earth even existed. Light never truly disappears. Even when it fades, it leaves echoes, reflections, shadows, radiation, whispering across the universe. Astronomers call this the cosmic background, the faint afterglow of the Big Bang, the original light still humming softly in every direction. It's proof that nothing in the universe is ever completely gone. Every photon that leaves a star travels outward forever, its energy dispersing but never dying. Somewhere far away, light from a supernova that exploded before humans existed is still moving through space, still shining, still alive in motion. And perhaps the same is true for us. Maybe every thought, every act of kindness, every spark of creativity we release ripples outward forever too. Our small echoes woven into the fabric of existence. When scientists study the formation of new stars, they see a universe that never wastes a thing. Even the coldest, loneliest atom has a role in the cycle. Every element forged in death becomes the foundation for life somewhere else. The carbon from a red giant's breath becomes the trunk of a tree. The calcium from a supernova's core becomes the skeleton of a bird. The oxygen that once burned in a sun becomes the air you're breathing right now. You are, in every literal sense, a continuation of stars, a living link in a cosmic chain that has no beginning and no end. When you touch your own heartbeat, you're feeling the rhythm of that same balance that once held us sun together. When you close your eyes at night, the photons that enter your mind come from stars still far away. Their light began its journey before you were born. You are surrounded by time, bathed in memory, woven into light. Now, here's a thought. What if the universe created stars and then created life just so it could look back at itself and say, "Oh, that's me"? Maybe we are the universe's way of noticing its own beauty, of hearing its own music, of remembering what it's capable of. Carl Sagan once said, "We are a way for the cosmos to know itself." And maybe he was right. You are not separate from the stars. You are their consciousness, their reflection, their dream continuing in another form. Billions of years from now, our sun will swell, fade, and die. Earth will be gone, but the matter that once made it and us will travel outward again. It will mix with other clouds, other dust, other memories, and perhaps someday, somewhere, another world will form. Another sky will shine, and under that new sky, another being will look up and wonder who they are, where they came from, and why the stars feel so familiar. And maybe, just maybe, they'll be breathing atoms that once belonged to you. So, as you listen now, as you breathe, pause for a moment and feel the weight of what that means. You are made of ancient light. You are the memory of stars that burned long before you. And you will be part of the stars yet to come. You are not small. You are vast beyond measure. Every heartbeat is a cosmic rhythm. Every thought, a flicker of fusion. Every act of love, a tiny supernova in the darkness of another soul. You are what the universe looks like when it decides to dream. Thank you for drifting through the stars with me tonight. If you are still awake, look up the next time you see the night sky. Every sparkle you notice is not just light, it's history, it's memory, it's home. And if you've drifted into sleep, that's alright too, because even in your dreams, the same stars that made you are still shining above. The universe is still expanding, and maybe so are you. Sleep well beneath the same stars that gave you life.